Nope. That's what I do all day. Yeah. All right, properties of logs. So guys, here's what this day is going to be all about. I'm going to show you a couple of different rules that you can apply to logarithms to help you either, well, pretty much, these are always going to help make things look a little bit less terrible. Okay, so these rules, we're going to use them to simplify some logs here and there. So before, how do I want to do this? Okay. Do you want to do this on your own Desmos, or do you want to do a group Desmos? Okay, group Desmos. Then let me get out Desmos real fast. So I'm going to get out Desmos just to show you this. All right, so it says graph log base 2 of 7x. So I'm going to type log 2, log 2 of 7x. All right, there's log 2 of 7x. Do you see it? Yes, it's great. It's red. Cool. What? Well, I can't change the color, so you have to deal with it. Okay, so there's log 7x. What does it say to do next? Graph this thing. So I'm going to graph that thing. Log base 2 of 7 plus log base 2 of x. Log base 2, log base 2 of 7 plus log base 2 of x. What happened? They are the same thing. What? See, look, red, this one's blue. They are the same thing. So this, what do you mean get to be small? Like to get the base 2, you got to hit shift and then you got to hit the hyphen button. Yeah, it's like next to backspace kind of. So that means this thing and this thing are in fact the same thing. They're the same graph, okay? And that's kind of what we're getting after today. Guess what? These are also the same thing. All right? I'm not going to show you, but those are the same thing. So here's my question. What'd you say? Multiply? How do you go from 7 and 4 to 28? You multiply 7 and 4, right? How do you take 7 and x and get 7x? You multiply them, yeah? So this is a rule, okay? This is a rule that you just found in Desmos. And the rule is this, the product property of logs. In math language, it looks like this. Log base b of m times n equals log base b of m plus log base b of n. You probably not, because you're not going to need it like that. There's an easier way to think about it. I mean, I can write it if you wanted to, but that's the math language. That's math language. Let's write it in other words, okay, in English words. Here's how I like to remember it. Multiplication in logs. So if you're multiplying stuff inside of a log, that is the same thing as addition of multiple logs. So if I'm multiplying some things inside of a log, the rule tells me that I can take those pieces, split them up into their own individual logs, and they're being added together, okay? I could also go the other way. I could take this and put them together inside of the log. You kind of see how this works? You can either split the log up or you can put the log together. and multiplication is addition. Does this make a little bit of sense? So let's do an example here. It says expand. No, that's what I want. It says expand this into multiple logarithms. Log base 4 of 5y. Well, this is 5 times y, right? And the rule is multiplication in a log is addition of logs, all right? So what are the pieces that are getting multiplied? 5 and y, so I can split them up. Those are the two pieces, so I'm going to break them up. It's log base 4 of 5 plus log base 4 of y. And there you go. So this is the same thing as that, and vice versa. That make sense? Okay. And try to break those up on your own. Hopefully this is not too bad. You're just taking the pieces and splitting them up. My YouTube production value is going down because I forgot to record that portion. So now I'm apologizing to my viewers. Yeah, I don't know. Am I trying to what? No, I'm apologizing to the masses that I know are going to watch this video because they didn't want. I forgot to record the other part. But are these okay? So tell me about this one. What is it? Wow. Yep. Yes, it does. So 2 rules we got so far. Multiplication is addition. Division is subtraction. Those are the 2 rules. There's one more, and it looks a little bit different. It looks like this. Again, I'm not going to show you in Desmos. Just take my word for it. This, log base 3 of x to the 4th, and this, 4 times log base 3 of x are the same thing. They match. They're the same thing. So the question is, how are these things related? What does that mean? Is there a number that moved? Yeah, what did the 4 do? It was an exponent, and then it came down in front, right? We're not really subtracting or adding or really doing anything. We're just moving a number, right? Same thing over here. I took the exponent, put it in front, okay? And that makes it match. So the rule is this. Again, in math language, it looks like this. Log base b of m raised to the n power is the same thing as n times log base b of m. That's the math language, all right? We want to write it in other terms. You can bring the power or the exponent, you can bring it in front and turn it into a coefficient. So it's not an exponent anymore, it's a coefficient. It's a number in front that's multiplying stuff. So if you have a power, bring it down in front. You could also go the other way. You could take a coefficient that's in front and you could put it back up top as an exponent, right? So you can go one way or you can go the other. Makes logs look less ugly. Pretty much. Yep. Yep. All right, here you go. Log base 2 of x to the 3rd. Remember, bring the power in front. That's the rule. Okay? So put the power in front. 3 log base 2 of x. Unbelievable. That make sense? Cool. Yeah. Oh, yeah, there's more. Don't even worry. All right, so now we've got the three rules. The three rules all individually are pretty easy, right? But in life, nothing is easy. Yep, especially not this class. And don't forget it. We have to be able to use the rules all at one time. We have to be able to use all three of them at once, okay? So I'm going to do two examples for you here. This is log base 2 of 5x to the 7th power. So remember, we got addition, we got subtraction, we got powers. The first thing I like to think, it says expand. That means I'm breaking it up into multiple logs, okay? What's going on inside the logs here? It's multiplication. Multiplication is what? Addition. What are the pieces that are being multiplied? 5 and x to the 7th, right? So take the two pieces and split them up. Are you okay with that? I just took the two pieces, I broke them up because multiplication in a log is addition of logs, yes? There's something else I can do though. I can bring the 7 to the front because you could bring the power down, right? Is it going to go in front of this? No, just in front of its piece, right? So put it in front of that term. It's log base 2 of 5 plus 7 times log base 2 of x, yeah? All right, let's look at the other one. Are we good with this? Yeah. What do you mean alone? Oh, like at the beginning? Yeah, you want to get the piece with the exponent in its own log, and then you can move it. Yeah. All right, let's think about this one. There's actually all three rules going on in this one. I have multiplication, I have division, and I have powers, right? What'd you say? Yeah. Yes. Yeah. So I got all three in this one. Okay, let me give you a pro tip. You should, if you have all three of them at play, you should do division first. If you're breaking it up and separating it into multiple logs, do the division first, okay? It's going to make life a little bit easier. Yes. Yes. Because let me ask you this. There's division in here, right? What are the pieces that are being divided? Well, you have what's on top and you have what's on bottom. So I'm going to split that up. So it's going to be what is on top minus what's on bottom. Yeah. Split them up first and then put the 3. Yeah. Yeah. What? Yeah. Yeah, we can, right? I split up the division, but now what's going on in here? There's multiplication, right? And multiplication is addition. So I can still break this up. I can turn this into log of x to the 3rd plus log of y minus, can I do anything to this? Yeah, I can bring the 5 down, right? This is a z. Yeah, I can bring the 5 down, so it's 5 log z. Yeah. Like what I want this in parentheses. You don't need them. If you did the division, what am I trying to say here? If you know how we did the division first? if you did the multiplication first and like split up the top part, then you would need the parentheses to show that you haven't done the division yet. But what we have right here is fine. Okay. All right, there's one more thing left. What can I still do? I can bring the 3, right? So it's 3 log x plus log y minus 5 log z. And now there's nothing else to do. Yeah. Does it look like this? Then it's fine. Yeah. So we did addition, we did subtraction, we did the powers. There's nothing else to do, and we're done. Cool? Okay. Nope. Try it. Hey, let me ask you this real quick. This thing. How many pieces are in the top? There's 3. 2, x squared, and y. So when you get to that point, you're going to do division first, right? So it'll be log of what's on top minus log of what's on bottom. But then that's actually going to split into 3 logs because there's 3 pieces. So the last ones were all about taking one log and breaking it up into multiple logs, right? So now we're going to go the other way. We're going to start with a bunch of logs, collect them, and put them all back together, all right? We're just going to use the rules in reverse. So let's think about this one. I have 3 logs. I'm going backwards now. I'm using the rules in reverse, putting it all back together. So as you're looking at this, you're looking at each piece one at a time. There's one rule you can apply right away to the middle one. Yeah, make it an exponent, right? I can take the 2 and I can put it up. So it's log of 3x plus log of 4 squared minus log of y. Okay. Now what's 4 squared? 4 squared is 16, right? So I can turn this into 16. So now that's log of 16. You guys okay with that? So I made this an exponent, right? So it was 4 squared, and 4 squared is 16. Okay? All right, so now I'm just using each rule one at a time. Let's just go left to right. This is log of 3x plus log of 16. Well, first question is, do these have the same base? Yes. What is the base? It's 10, right? Because it's not written, so you know it's 10. Addition of logs is what? Multiplication in a log. So I'm multiplying these pieces, 3x and 16. So it's log, what's 3 times 16? 48. So it's 48x. So I took those 2 pieces, I put them together, and I multiplied them, and it's minus log of y. So how do I finish it out? Division, because subtraction is division, right? So how are you going to write the final thing? 1 log. It's log of what? 48x divided by y. And that's it. You all right? Feel good? Okay. And let's do this one real quick. 3 log base 3 of x plus 4 log base 3 of y. They both have a base 3. What do you want to do first? Move them up. Move that up, move that up. So it's log base 3 of x cubed plus log base 3 of y to the 4th. Yeah. Like if this was a 4 as well, right? You're saying could you combine them and just leave the 4 in front? It depends on what these are. Because let's finish it and then you'll see why it might not work. So it's addition, right? So you can put them together. So it's log 3 and you're multiplying. So it's x to the third and y to the fourth. So that's it. You're done. There's nothing else to do. So if this was a 4, this would be x to the fourth, y to the fourth, which I guess you could say is xy to the fourth, and then leave it in front. So it would work there. If they were numbers, the numbers are going to change, right? So if they were numbers, kind of like you did here, you kind of want to just let the numbers change instead of leaving the exponent. Does that make sense? But it would work. Yeah, it could probably work. All right, feel okay about that? Okay. I'm going to show you one more thing, and then I'm going to let you guys practice for the rest of the day, okay? The one more thing is something called the change of base formula. It's not going to take us very, it's just a quick thing I got to show you. Let's say that you had that, log base 5 of 7. And let's say you want to know what that number is, right? Because it asks a question, right? What power do you need to raise 5 to get 7? Let's say you actually want to know what it is. Your calculator can tell you what this is. It's a decimal. Your calculator can tell you what it is. Here's how you do it. It's called the change of base formula. In your calculator, you would do log of the kind of the top number divided by log of the base number. Because remember, your calculator has a log button, right? It turns it into a log with a base of 10. So if you want to find what this number is, your calculator can do it, okay? You just have to do this in the calculator, log of the top number divided by log of the bottom number. All right? Did somebody do it in their calculator? 1.209. Okay, cool. So that means if you raise 5 to the 1.209 power, you get 7. Unbelievable. So that's called the change of base formula. It comes in handy when we actually want to know what the number is. So not too hard, just want to show it to you. Remember, if you want to figure out what it is, log of the top number divided by log of the bottom number in your calculator, and you got it. Okay?